All right, going over the 9.1, 9.3 quiz review. You guys should have finished all of these questions. I am going to go over number 17. That one was definitely a little challenging, but everything else should have been pretty easy. I believe on some of these questions you rounded using a decimal, but be aware your quiz is not going to have many decimals. You're going to have to simplify your radical to as simple as it can be. Okay, so you're not going to be asked to round. All right. Looking at the first one, find x. Tell whether the side lengths form a Pythagorean triple. All that means is, does it form whole numbers for all of my sides? Okay, that's all it's looking for. So for this, I'm going to solve using the Pythagorean theorem. Keep in mind your hypotenuse is what's opposite your 90-degree angle. So this is my C. So I'm labeling, I have A, I have B, I have C. Keep in mind A and B doesn't matter which one's which. And then solving it, I'm going to have 9 squared plus 12 squared equals C squared. And I'm solving for C. 9 squared is going to give me 81 plus 144 equals C squared. Adding these two together, I'm going to get 225 equals C squared. And when I'm getting rid of that squared, I'm square rooting it. So for this one, I'm going to have C equals 15 because 225 is a perfect root. Is this a Pythagorean triple? Yes, I have a 9, 12, 15 triangle. Those are all whole numbers. So this is yes. It is a Pythagorean triple. Okay, so you should have had a few answers. You should have had X, and then if it's yes or if it's no. All right, looking at number 2. Same thing. This is my hypotenuse, so this is my C. It's opposite my right angle. This is my A. This is my B. So putting solving it in the rule, I have A squared plus B squared equals C squared. 8 and 8 is 64. 7 and 7 is 49 equals C squared. Add these two together, I'm going to get 113 equals C squared. Square root it. And I cannot simplify the square root of 113. So C is going to equal the square root of 113. Again, please do not change it to a decimal. It needs to be simplified as simple as possible, and this is it. So this is not a Pythagorean triple. Because it would be a decimal. Okay, so this is no. So I solved for my X, and then I answered if it was. Looking at 3, same thing. This is opposite my hypotenuse. This is opposite my 90-degree angle, so this is my hypotenuse. I'm going to have A, B, and then C was 8. So solving it, labeling it, I'm going to have A squared plus 4 squared equals 8 squared. I'm solving for my A. 16, bringing everything else down, and 8 squared is 64. Solving for A, I'm going to subtract 16 first. And I have A squared equals 48. Square rooting it, get rid of that square. And A is going to be simplifying this, breaking it down. I have 16 and 3. 16 breaks down to 4 as a whole. And A equals 4 radical 3. All right, and this one is not a Pythagorean triple. All right, looking at the next question, it says, verify that this segment lengths form a triangle. Is the triangle acute, right, or obtuse? So for this one, I need to figure out Is my hypotenuse equal to, less than, or greater than? Keep in mind your hypotenuse is always the larger number. So looking at this one, my hypotenuse is 40. I'm going to put 40 squared. A little blank because that's what I need to figure out. 24 squared plus 32 squared. So I'm going to have 1,600, 1,024 plus 5, or flip it around, 576. I'm going to add these two together. So adding them, I'm going to get 1,600, and they're equal to. So this is a right triangle. All right, looking at the next one, 13 is my larger number. That is my hypotenuse. So I'm going to have 13 squared with a blank, 7 squared plus 9 squared. 13 squared is 169. 7 squared is 49 plus 81. I have 169. This is going to be 130. My hypotenuse is greater than the square root of my other two sides. So this is obtuse. Okay, please keep in mind that I do put my hypotenuse first. That's normally how the rule was. If your hypotenuse is greater than the other two sides, and they're squared, it's obtuse. If it's less than, it's acute. So let's go ahead and look at this next one. If you're not sure which one your hypotenuse is, just plug it into the calculator. 10 times the square root of 3 is going to give you, what, like 17, 18? So that's your largest side. And keep in mind you are squaring everything. So you're going to take your 10, square root 3, everything is squared. And then you're going to have 12 squared plus 15 squared again. Please be aware if you're plugging that into the calculator, if you're plugging this into the calculator, you have to put parentheses around everything. If you are not putting a parentheses around everything, it's going to be it's going to give you the wrong answer. Okay, you don't necessarily need a calculator for this. 10 squared is going to give you 100. And if you're squaring a square root, just take it out. That's just going to give me a 3. Okay? Because the square root of 3 times the square root of 3 is the square root of 9, which is a perfect root. Looking at the next side, 12 times 12 is 144. 15 is 225. This is going to give me 300 and 369. If you're looking at it, my hypotenuse is smaller, so this is an acute triangle. All right, looking at 7, 8, and 9, it says find the values of x. Write your answer in simplest form. So they want me to solve. So for this, I'm given a special right triangle of 45, 45, 90. So I need to go ahead and plug in. All right. Like I said, 45, 45, 90. So labeling what I have, opposite of your right angle is your hypotenuse. And for a 45, 45, 90 triangle, your hypotenuse is going to be a times the square root of 2. And then your two congruent sides are going to be a. So they want me to solve for x and they want me to solve for y. I know what my value of a is. X equals a, and we know a is 6. So looking at this one, x is going to equal 6. And then again, all I'm doing is plugging in. Y equals a radical 2. And again, we know what a is. So y is going to equal 6 radical 2. I cannot simplify it, so these are my answers. Looking at number 8, this is a 30, 60, 90. And again, labeling it. Opposite of 30 is a. Opposite of 60 is a radical 3. And opposite of x is 2a. And again, I know what my a is, so I'm plugging it in. Let me change this to 2a, not 2x. Okay, plugging in for x. X, I have 2 times 8, because again, a equals 8. So x is going to equal 16. And then for y, I have y equals 8 times the square root of 3. And it's simple as it can be. And these are my 2 answers for x and y. All right, looking at number 9. 30, 60, 90 again. So opposite of 30 is a. Opposite your hypotenuse, or opposite your 90-degree angle is your hypotenuse, which is 2a. Opposite of 60 is a radical 3. And this one's not giving you a, so I have to solve for a. All right, so I'm going to have 2a equals 10 times the square root of 2, and I'm solving for a. So I'm dividing both sides by 2. A equals, keep in mind this can be simplified. If you simplified it all the way, you're going to get 5 times the square root of 2. And that's what a equals. So if x equals a, x equals 5 times the square root of 2. And then I'm plugging it in for y. I'm taking that entire thing and plugging it in for a. So I have 5 times the square root of 2 times the square root of 3. You could combine these. You're going to have y equals 5 times the square root of 6, and you cannot simplify that. That's as simple as it can be. So these are my answers for x, and this is my answer for y. All right, find the geometric mean of the two numbers. So geometric mean, all you're doing is square rooting your square rooting the product of the two numbers. However, I'm not going to combine my two numbers. I'm going to keep them separate. So I'm going to have x equals the square root of 6 times the square root of 12. Why am I breaking these two up? Because it's eventually going to get there if I multiply them together. So if I'm breaking them apart, if I'm factoring them out, I'm going to have the square root of 3 and the square root of 2. And for 12, I'm going to have the square root of 3 and the square root of 4. Are any of these perfect roots? Yes, my 4 is. So this is 2 as a whole. And then I have 2 of the same square roots. So I'm going to take the number out, okay? Just so you know, the square root of 3 times the square root of 3 is going to equal the square root of 9, which is a perfect root. So I'm just taking my 3 out. So what do I have left over? I'm going to have 2 times 3 times the square root of 2. And if I solved this, I'm going to get 6 times the square root of 2, and that's my answer. Again, you could always check your work if you multiply 6 and 12. Okay. And then multiply 6 squared times 2, and you should get the same answer. Looking at number 11, I have 15 and 20. So again, doing the same thing. I have the square root of 15 times the square root of 20. Factoring them out, because I can, I'm going to get the square root of 5 and the square root of 3. And then for 20, I'm going to get the square root of 5 and the square root of 4. 4 is a perfect root. And then looking at it, I have square root of 5 and square root of 5. So what I have left over is going to be 2 times 5 times the square root of 3. So evaluating it, I'm going to have 10 times the square root of 3, and that's my answer. Again, on your quiz and upcoming tests, you guys will have to simplify your radicals. So please make sure you are simplifying. All right, And the last one for this section 12, I'm going to have the square root of 18 and the square root of 26. I'm going to get 9 and 2. And then for 26, I'm going to have the square root of 2 and the square root of 13. So 9 is a perfect root. It's going to give me 3. And then again, I have two 2's. So what do I have? 13 is a prime number, so I can't do anything. So I'm going to have 3 times 2 times the square root of 13. And again, solving this out, I'm going to have 6 times the square root of 13, and that's my answer. All right, solving the next question, it says identify the similar triangles, then find the value of the variable. So they want me to find my similar triangles. So looking at my similar triangles, there are 3 triangles here. Looking at them, finding them, I'm going to have my larger triangle, which is in purple. I'm going to name it triangle BCA. That's similar to this triangle right here. And that is triangle, again, following that same pattern, DBA. And my last one, this is my triangle right here in green. And this one, I'm naming it triangle DCB. All right, so identify the similar triangles. Now they want me to find the value of the variable. So if you're looking at this diagram, this is my I'm looking for my altitude. Okay, x is my altitude. So I'm going to use the rule that has altitude in it. Why? Because I'm also given my 2 segments. So the rule is segment 1 over your altitude is equal to your altitude over segment 2. So plugging that information in, I'm going to have segment 1 is 8 over x equals x over 4. Cross multiplying, I'm going to get x squared equals 8 times 4. And then getting rid of that squared, I'm going to square root it. I'm going to have, factoring my 8, the square root of 4 and the square root of 2. The square root of 4 is a perfect root. So left over for x, I'm going to have 2 times the square root of 2. So x equals 4 times the square root of 2. And again, you should have this written as well as solving for my variable. All right, looking at the next question, following the same thing, I'm going to go ahead and find my similar triangles. So I have this triangle right here, my larger triangle, which is going to be triangle. I'm going to name it FEG. That's similar to triangle. Let's go ahead and do this one. Triangle HFG. And that's similar to triangle, the last one right here, HEF. All right, now I'm going to go ahead and solve for y. Looking at y is my leg. Please keep in mind, it is not your hypotenuse. You're looking at the entire triangle, this entire right triangle. Okay, this is my hypotenuse because it's opposite my 90-degree angle. Do not look at this little triangle and say, why is your hypotenuse? It is not. It's for the entire right triangle, the entire thing. So if I'm solving for a leg, I'm going to use the rule with my leg, geometric mean for my leg. So I'm going to have my hypotenuse over leg equals leg over your SOHAL. Okay, the segment of the hypotenuse adjacent to the leg. So looking at it, my hypotenuse, we should know what our hypotenuse is because we're adding 6 and 9. That's my hypotenuse. So my hypotenuse is going to be 15 over my leg, which I don't know, equals my leg over the segment of the hypotenuse. So here's my hypotenuse. I have two segments, 6 and 9, but the one that's adjacent to the leg. So if I'm trying to solve for y, adjacent means next to, and I'm using my 9, not my 6. So y over 9. Now I'm going to go ahead and cross multiply. You're going to get y squared equals the square root of 15 times the square root of 9. Factor these out. I'm going to get the square root of 5 and the square root of 3. 9 is a perfect root. So I'm going to have y equals 3 times the square root of 5 times the square root of 3. So y is going to equal 3 times the square root of 15. Okay, so again, you have your similar triangles. You identified your similar triangles, and you solve for the variable. All right, looking at the next one, 15. Going ahead and finding those similar triangles. So I have my large triangle right here. I'm going to have triangle, let's do KJL. That's similar to triangle. This one right here. MKL. And that's similar, oops, that one should be in green. Just so we color coordinate them. And then that's similar to triangle. This is going to be MJK. Don't forget your triangle sign. All right, now we're solving for our hypotenuse. I'm going to use the same formula I did for the last question because it involves my hypotenuse. And all I need is a leg and my SOHAL, which they're giving me. So the rule for this was your hypotenuse over your leg equals your leg over your SOHAL. So plugging in what I have, I do not have my hypotenuse. So that's my z over my leg, which is 18, equals 18 over 12. Cross multiply, I'm going to get 12z equals 324. Divide by 12, and z is going to equal 27. All right, questions so far on the first 15. These ones should have been pretty easy, per se, very concrete answers. Questions on the first 15? All right, 16 and 17. 16 was a little challenging for some people, it says. Television sizes are measured by the length of their diagonal. You want to purchase a television that is at least 40 inches. Should you purchase the television shown? Explain your reasoning. So, yes, this is a rectangle. However, we don't know if it's a special right triangle. If there's a special right triangle here after I make my diagonal. So here's my diagonal. Yes, all of these angles are 90 degrees. But we don't know if it's a 30, 60, 90, and we know for sure it's not a 45, 45, 90. So looking at this diagram, I'm trying to solve for my hypotenuse, which is my diagonal measure, which they told me that's what I'm trying to find. So I'm using the Pythagorean theorem. Okay, so if you did not use that, please make sure you're using that. I'm using my Pythagorean theorem to find my hypotenuse. Okay, that's what I'm using to solve for my x. So, plugging it in, I'm going to have 20.25 squared plus 36 squared equals x squared. I'm going to get 410.06 plus 1,296 equals x squared. Adding these two, 1,706.06 equals my x squared. And square rooting it. If you plugged it into the calculator, your x, or your hypotenuse, should have been 41.3, about 41.3, okay, because I believe we rounded. So, should we purchase this TV? Is it larger than 40 inches? Is it at least 40 inches? Yes, it is. Because my diagonal is about 41.3. Okay, so it does qualify as larger than 40. All right, and looking at the last question, there was a lot of parts to this one. It says each triangle shown below is a right triangle. Are any of the triangles special right triangles? Explain your reasoning. So if I'm looking at these, yes, there are 4 special right triangles. Looking at these special right triangles, what do I have? A is a special right triangle. How do I know? Because this is an isosceles triangle. Both of my sides are going to be congruent. So I have a radical 2, and this is a 45, 45, 90. All right, looking at B. Let's say if I made this a 30, 60, 90 triangle, let's see if it follows that qualifications. Let's say that this is A. This is a radical 3, and this would be 2a. Yes, that works. If a is 3 and I plug it in for a radical 3, it would be 3 radical 3, so that would be a 30, 60, 90. Looking at C, again, let's double check. If this was A, this is A, and this would be A radical 2. That works. So this is a 45, 45, 90 triangle. If I'm looking at D, I know it's not a special right triangle because my sides would be congruent if it was a 45, 45, 90. And if it was a 30, 60, 90, regardless, I wouldn't have a side that's 3 and 4, so that wouldn't work. And then let's look at the last one. It's not a 45, 45, 90 because if this was A, this would be A radical 2, and that wouldn't give me 10. So let's go ahead and try 30, 60, 90. So this would be 30. Let's see if it's 60. This would be A. This would be A radical 3. And this one would be 2a, which works. So, labeling. Are any of the triangles special right triangles? Yes. What do I have right now? I'm going to have my A and my C are 45, 45, 90 triangles. And then my B and E are 30, 60, 90. All right, list all similar triangles, if any. So yes, that kind of states which ones are similar. Triangle A is going to be similar to triangle C, and triangle B is going to be similar to triangle E. And the last one says find the lengths of the altitude of triangles B and C. So I'm going to go ahead and do C first. Looking at C, keep in mind your altitude goes straight down. And it makes that 90-degree angle right here. Keep in mind, if this was a 45, 45, 90 triangle and I went straight down, this will continue to make it a 45, 45, and 90 degree down here. So if 6 is my hypotenuse, 6 would be my A radical 2. This is my A. This is my A. Again, they asked me to solve for my altitude. So my altitude would be considered my A. So I need to solve for A, given that 6 is A times the square root of 2. So solving, I have A times the square root of 2 equals 6. Divide by the square root of 2. I cannot have a radical as my denominator. Okay, so I'm going to have 6 over the square root of 2 times the square root of 2 over the square root of 2. I'm going to get 6 times the square root of 2 over 2. And this can be simplified. So my new A would be 3 radical 2 over 2. Okay, so for this one, that would be my answer. Or no, this would simplify to something else. What am I doing? It would just be 3 radical 2. A equals 3 radical 2. That's for my altitude for C. Let me go ahead and find my altitude for B. So looking at B again, I'm going to go ahead and draw that line. It's that 90-degree angle right here. And using the information that I have, I'm going to go ahead and look at this triangle over here. This is what I'm going to use. So I have my 30, I have my 60, and my 90. So this is going to change to my 2A because it's opposite my hypotenuse. This is going to be my A, and this is going to be my A radical 3. So first thing is I have to solve for A. That's all I have to do. So I'm going to have 2A equals 3 times the square root of 3. Divide both sides by 2. And again, I'm solving for A. A equals 3 times the square root of 3 over 2, and I'm done. Okay, so if you were not able to do the last question, that was fine. It was definitely a little challenging if you didn't understand what it was asking. But please check your work. All of this is on Canvas, so you can always check it if you need to. But you have one more review to work on.